Are you also among those who believe that we are not alone in this vast universe? Do you think that life exists only on Earth in this enormous expanse? If we approach this phenomenon mathematically, we obtain some findings that suggest the answer is no. Let's explore how likely it is for life to exist in the universe and try to understand why the universe is so vast. The number of stars in the observable universe, estimated to be between 100 billion and 400 billion, implies the existence of an equal number of galaxies in the observable universe. In other words, for each star in the vast Milky Way galaxy, there exists a whole galaxy out there. All of this generally corresponds to an estimated range of total stars between 1022 and 1024. This means there are as many stars as the total grains of sand on all the beaches on Earth. The scientific community believes that 5% to 20% of these stars are Sun-like. Let's consider the lowest estimate, 5%. For the number of stars, let's take the lower limit of 1022. This gives us an expression of 500 quintillion, or in other words, 500 billion times a billion Sun-like stars. There is a debate about how many of these Sun-like stars are orbited by a planet similar to Earth. Some say it could be as high as 50%. However, a recent study concluded that this number is around 22%. Let's stick with the lowest estimate of 22%. This suggests that at least 1% of the total stars in the universe, or 100 billion times a billion, potentially have Earth-like planets that could support life. Can you grasp how large this number is? Let's imagine that in just 1% of the Earth-like planets that have existed for billions of years, life develops, and in just 1% of those planets, life evolves to a level similar to that on Earth. This implies that there are 10 trillion, or in other words, 10 million times a billion advanced civilizations in this observable universe. If we focus only on our galaxy and apply the same mathematics to stars in the Milky Way, we can estimate that there are over 1 billion Earth-like planets and over 100,000 advanced civilizations in our galaxy alone. So, if we are not alone and the probability suggests a high likelihood of life beyond us, why haven't we found any evidence of extraterrestrial life yet? This question arose years ago when the renowned physicist Enrico Fermi, part of the Oppenheimer team working on the atomic bomb project at Los Alamos, asked his famous question during lunch, "Where is everybody?" This question gave birth to the Fermi Paradox in 1998, proposed by Robert Hansen. The Great Filter hypothesis is grounded on assumptions about why we haven't interacted with extraterrestrial beings. Essentially, it can be thought of as a galactic adaptation of natural selection on Earth. The first assumption is that we are the most advanced beings in the galaxy. Perhaps we are the most advanced beings in our galaxy, and other life forms are currently at a very primitive stage. Many science fiction movies depict aliens as highly advanced beings with superior technologies and advanced civilizations. Even the UFO phenomenon, where an alien being teleports into a vehicle with a sudden burst of light, is a product of this fantastical thinking. But what if the extraterrestrial life we are searching for is a single-celled primitive organism or a life form like a worm or fungus? In that case, it wouldn't be abnormal for our messages sent to communicate with them or the telescopes sent into space to observe them to find no evidence. Our efforts to search for them in this vast space would be challenging. Currently, human technology's reach into space is, in reality, quite limited when considering the entirety of space. Another hypothetical scenario is that advanced civilizations once existed but self-destructed with their advanced technologies. Their high-level technologies might have led to their own demise due to a war among themselves. Consider the strides humanity has made in science and technology, creating and detonating nuclear bombs. At the time, those working on such projects were awarded Nobel Prizes for unleashing incredible energy. Nuclear energy is a significant power source for many developed countries, leading to significant advancements in various fields from production to efficiency. However, can you imagine the potential consequences of the misuse of this technology? In the event of a possible war, countries resorting to nuclear weapons could bring about our own destruction. While we may not have the power to discover any extraterrestrial life, we do have the power to easily destroy a planet. Think about the time when the first atomic bomb was tested. Physicists mentioned the possibility of the atmosphere catching fire and the world potentially ending, but the bomb was tested, and even the developers didn't fully know what to expect. This bomb was used 3 times, meaning our world has narrowly escaped this danger several times. Perhaps one of these scenarios has befallen civilizations far more advanced than ours. They might have entered a cycle where they destroyed each other before reaching the technology to communicate with other life forms. Or could we be one of the civilizations currently caught in that cycle? Only time will tell. Another assumption is that more advanced civilizations might not bother to communicate with us. These civilizations may find us uninteresting because they possess technologies and possibilities beyond our comprehension. Similar to how we might not pay attention to ants or insects when walking in nature, these civilizations might have evolved to meet their energy needs from stars and have advanced to a level where our concerns are trivial. They could be owners of things we can't even imagine or dream of having. Perhaps they've explored many different civilizations before and finding life beyond themselves is not as intriguing or exciting as it is for us. They might not even be actively searching for it. Maybe they have news about us, but descending to our primitive level doesn't hold any meaning for them. We could be the ants that they find uninteresting. But what if none of these possibilities are true? Could we really be alone in this universe? The transformation of lifeless molecules into living cells might be even rarer than we assumed at the beginning of this video, possibly occurring only with an extremely low probability on our planet. Of course, over the billions of years that followed, the evolution of life and the parallel development of our planet, in perhaps trillions of combinations, could have led to our existence. This life might have emerged through the perfect harmony claimed in some religions, orchestrated by a higher power. These topics are still debated by philosophers, scientists, and religious leaders. There are hundreds of hypotheses like these. Which one do you find more likely? Which assumption, in your opinion, has a higher chance of being true? Feel free to share your thoughts in the comments. If you've watched the video until the end, don't forget to like the video and support our channel with your subscription.